Hello, welcome back student to design and analysis of algorithm subject. This is common for the CSE as well as the IT in the third year. Before going to the today's topic, we will going to see what we have completed in the last class. In the last class, we completed n-queen problem and we have taken the example of 4-queen and we solved the problem. Okay, using the backtracking. If you did not see that, go and watch the previous video. Okay, now today we are going to see the 0 by 1 knapsack problem using branch and bound technique, or we can say branch and bound approach or branch and bound method. So any one of the things you can say: approach, branch and bound technique, method. Okay, anything you can say. So here the next is branch and bound. What is branch and bound? Branch and bound is an algorithm design paradigm which is generally used for solving combinators operational. Next, these problems are typically exponential in terms of time complexity and may require exploring all possible permutation in worst case. Okay, like if you going to find all the possible solution, then it will be a exponential. Okay, so that is very difficult. Exponential is the one of the worst case in the time complexity. Okay, next, the branch and bound algorithm technique solve this problem relatively quickly. Okay, so with the help of this technique, branch and bound means we will do one thing. We will make a branch and we will apply the bonding function, and we will stop the process if that is not up to the mark or desired output. Okay, so this is branch and bound. Okay, so in the 0 by 1 knapsack problem, we are going to see the example this. Okay, this example I am going to take the 4 items. Okay, and that 4 item profit is there and weight is there. Profit and weight. What is the item 1? The profit is 10, and what is the weight? 2. Less weight and profit 10. Item 2, 10 profit, 4 is the weight of this. Okay, and the third one is 12 is a profit and the 6 is a weight, and here 18 is a profit and 9 is a weight. But branch and bound technique, we are going to find the optimal solution. As I told you, optimal solution is nothing but whenever we need the maximize the value, you can take the maximum. Whenever you want the minimum, you can take the minimum. So for this branch and bound technique, we are going to take the minimum. Okay, that means whatever the value here in the positive, we are going to give minimizing, means in the negative, minus sign. Okay, and for this, how we will get the cost and profit? Whenever you are going to solve, okay, branch and bound, solve this m and 4. What is the m? M is a back capacity of the, here this is a back capacity and this is number of items. So after adding the item, is the total back capacity should be 15. So how to do that? Already we have completed the 0 by 1 knapsack problem with the while using the dynamic programming. Okay, but now here we are using the branch and bound technique with the same problem. And as you know, the 0 by 1 knapsack, what does it mean by? It will not take the fraction value. Okay, it will not take the fraction value. So here, for solving this branch and bound technique, you must know the upper bound. Okay, you must know the upper bound and you must know the cost. Okay, these two things you must know the solve the problem. Okay, and upper bound, in the upper bound, okay, there will be a sigma. Okay, the total sigma pi and xi. After adding this, you must get the value. Here from I to n. Okay, pi xi, cost. Here what we will do here with this formula, okay, here sigma from I to n, pi xi, but here we will, in the cost, we will add the fraction, means with fraction, but here without fraction. We need to add without fraction in the upper bound. In the cost, we need to add with the fraction. Okay, so what is this and how to solve? We will solve here. Okay, so this is a problem we have, 0/1 knapsack problem. Okay, so here, like example, what is a, and here in the branch and bound technique we have the LCBB. LCBB is least cost branch and bound technique. Least cost branch and bound technique. Least cost branch and bound. Branch and bound. Okay, I will reduce the size. Fine. So here what we need to do, first we need to calculate what is the upper bound and what is a cost. So here, and the same time we need to concentrate on the weight. Okay, we need to check the weight also. Weight should not increase more than the given size. Okay, so here in this problem, like if I add this 10, the profit is 10 and the weight is 2. When I am adding this, what is happening? We can add this 2. Yes, we can add, because 15 minus 2 is 13. Still the 13 space is remaining. We can add this item 1. Then if I take the item 2, the total cost of 4, then after from 13, from this 13, if we minus 13 minus 4 is 9. Okay, if I add the third item 6, 9 minus 6, 3. Yes, I can also add the item 3, but when we go to the item 4 here, we cannot add here, because what is the remaining size? Weight of the bag is 3, but here for the 18 is 9, and we cannot take the fraction in the upper bound. Okay, so here when we are adding this, okay, when we are adding this, So first you need to take the, here two things are there, two things are here. First one is x1 is equals to 1, means item 1 is 1, that means we are adding. X1 is equals to 0. What does it mean by x1 is equals to 1? Means we are adding in the box. Okay, we are adding in we are adding because we are adding the 3 items. Okay, so that means whenever you add any one of the item, you should write the 1. If you are not writing the item, you should remove the item. So here, what is the cost? As I told you, cost and upper bound we need to find. So what is upper bound here? 10 sigma of 1 2 3 10 plus 10 plus 12. Okay, and what is the weight capacity? Weight is 2 4 6. Okay, but still the remaining, here we are adding, what is the total cost? 6 plus 4 plus 2 is 12. So we can add all 3 items. So what is 10 plus 10? 20. 20 plus 12 is 32. Okay, so what is our upper bound now? Upper bound is minus 32. As I told you, we are converting the profit, converted the maximum problem to minimization problem. So we need to write the minimum. Okay, I will write this in different color. U is equals to minus 32. Here we are not adding the fraction. Okay, what about the C? C, I can add 10 plus 10 plus 12, and this 2 4 6. And here, what is the remaining size? Remaining size is 3. So here we can take the profit 18 divided by 9 multiply by 3. What is the remaining size? 9 ones are 9, 9 twos are 18, 2 threes are 6. So we are getting 6. Okay, so what is our cost now? Our cost is 10 plus 10 is 20, 20 plus 12 is 32, 32 plus 6 is 38. C is equals to minus 38. Okay. Okay. So here x1 is equals to 1, means when you are adding this 1, when you are adding this, when you are adding this 1, so you will get the same thing. Yes, I am adding. So whatever the value here, the same thing you are going to get here. Minus 32. C is equals to minus 38. Because how did I get this value? After adding the first item. Okay, if I did not add this, so we need to remove now. Okay, we need to do the same, like U is equals to, we no need to add the first item. Now we are removing the first item. So I am going to add from the second. 10 4. Okay, 10 4, then 12 6 10. Okay, but here I cannot add. What is the remaining? 4 plus 6 is 10. So what is the remaining? Remaining is 5. But here we have the 9, so we cannot add. So the same thing, 18 by 9 multiply by 5. 9 ones are 9 twos are. Okay, so what is the total cost? Is 10. 10 plus 12 is 22. 22 plus 10. Oh, sorry. Here fraction value we are going to add in the C, not in the U. Okay, in the U you will get the same 4, 12, 6. That's it. So here in the C we are getting the total is 32, and here we are getting the value 22. Okay, after excluding. So here when we take U is equals to, okay, what is U is equals to minus 22. Okay, this is we are doing the minimizing, and C is equals to minus 32. So here first we are considering the upper bound. Okay, upper bound is infinity. First we are considering the upper bound is infinity, but when we are getting the upper bound here minus 32 is less than, so just cut this. What is the thing? 32. We need to add the sign also, minus 32. Okay, minus 32. So from this U, from this, which one is a minimum, we need to keep that one. So minus 22 is the highest number compared to minus 32. Okay, so here we are applying the bonding function. We are stopping here because we need to find as much as possible for minimum. Okay, fine. So this is done. If we include the first item, we will get this. If we exclude the item 1, we will get this one. Okay, the next one. Here if I include second item x2 is equals to 1, here if I exclude, sorry, that is 0. Okay, include and exclude. What about the include? In the first itself we saw that we added the second item also. Okay, so here the value will be the same, the value will not change, and cost is equals to minus 38. Okay, but what about 2? If I do not add the item 2, then what will be the answer? Let's check it out here. Here U is equals to, I am adding the first item. Okay, 10, and what is the weight? Is 2. Now I am not adding the second item. So what is 12, 6. Next one is 12, the weight is 6. 6 plus 2, 8. 8 plus 9, it will take the fraction. So here we cannot add here. Okay, we need to stop here because here we are going to get the fraction value. So what is the upper bound? 22. So here U is equals to minus 22. Now again see the cost. Cost is equals to same thing. First item we added, third item we added, fourth item. What is the remaining? 15 minus 8. So what is the remaining size for the 15 minus 8? Is remaining is 7. So here, as we did the fraction for the cost, okay, the same thing here we need to do. 18 divided by 9 multiply by 7. Okay, 9 1s are 9, 9 2s are 18. 2 7 the 14. So what is the total here? 14. What is the overall of cost? 14 plus 12 is 26. 26 plus 10 is 36. What is the answer we are getting? 36. So here C is equals to minus 36. Now check what is our upper bound is minus 32 and here minus 22. So here also we are applying the bonding function. Okay, bonding function, because the value what you are getting in the upper bound is more than what we have now. Okay, next, again if I add the third item also, x2 is equals, sorry, x3 third item is equals to 1. If I add here, if I don't add the third item, okay, now if I add in the first itself, we saw here we added 1 2 3, so the value whatever value you got for the upper bound and the lower upper bound and the cost, that the same thing we will have here. So what is that? U is equals to minus 32, C is equals to minus 38. But if I remove the third item from the given problem, okay, third item from the given problem, so what will be the answer? Here U is equals to first item I am adding, second item I am adding, but I am not adding the third item, I am adding the fourth item. Okay, so what is the here in the table? The weight 249. Okay, 249, the weight 249. So what is the total now? 9 10 11 12 13 14 15. So we got the answer is 15 here. But what we got here? Here we got the 38. So here if we don't add the item number 3 in the back, then what is the value you are getting for the upper? For the upper, U is equals to minus 38. Okay, and what is the C? We need to find the C. C is equals to when we add 10 1 2 and fourth item, we will get the same answer. Okay, 15, and here we will get the 38. Okay, so what is the cost now? Cost is also the same, minus 38. Okay, so here without fraction we got the 38. So now what we have now, minus 32 is higher and minus 38 is a lower. So what we need to do? We need to cut this and we need to write minus 38. So what is the upper bound now? Now the upper bound we have minus 38. We are finding the minimization problem. Okay, now if I go further here, okay, if I go further here, if I include x 4, I cannot add here. Sorry, I cannot add here because minus 32 is higher than minus 38. So we cannot go further. So here we will apply the bounding function. Okay, we are apply the bounding function. This is not a feasible solution, so we can say this is infeasible. Okay, this is not a feasible solution. So now we need to go further here. Okay, if we add x4 is equals to 1, x4 is equals to 0. If we add x4 in this, so what the answer you are going to get? You are going to get the same thing. U is equals to minus 38, C is equals to minus 38, because here we added the fourth one. Okay, so here you will get the same thing, minus 38, C is equals to minus 38. Okay, but here if we don't include the fourth item, okay, if we don't include the fourth item, what will be happen? Here U is equals to, we are adding here, if we follow the rule, we are adding 1, we are adding 2, we are not adding 3, we are not adding 4. So what will be the answer? Just we are adding the first item and we are adding the second item. We are not adding the rest of the items. Okay, so what is the answer you are going to get here? You are going to get here is 20. Okay, the weight is 6, but we cannot add any more item here because we are removing the 4 as well as the third. Okay, C is equals to 10, 10, this is 2 and this is 4, and here also you are going to get the 20. Okay, here also you are going to get the 20. So what is the upper bound now? Upper bound is minus 30, sorry, upper bound is minus 20 and cost is minus 20. So minus 20 is greater than minus 30. Because of that, we are not changing here and we are stopping here. We are applying the bounding function, or it is not feasible. This is not feasible. Okay, so here what is the route we follow now? Here when we add this one, okay, concentrate on the green line. I am adding the item number 1 and I am adding the item number 2 and I am not adding item number 3. Okay, and I am adding item number 4. When I do this, what is the answer I am getting is minus 38, minus 38. This is a minimization problem, and for this we will use two methods, fixed variable and fixed answer and the variable answer. So here you can write like in the bracket you can write 1, means I am adding this 1 first item and I am adding the second item also, but I am not adding the third item, so write it 0, and I am adding the fourth item, so this is x1, x2, x3, x4. Okay, so this is the answer. That means I am adding the item number 1, I am adding the item number 2, and I am not adding item number 3, I am adding the item number 4. So when I am adding this, so what is the total weight? So what is the weight? M is equals to is 30, sorry, M is equals to 15. Okay, so this is a final answer. So least cost branch and bound technique we used, we converted the maximum problem to minimization problem. Okay, with this is a textbook example, so you can check this 1 2 3 4 item, and we are solving one by one, and we got the answer here. Okay, so this is a problem and we got the answer. What is the answer now? First item I am adding, second item I am adding, but I am not adding the 0, and a third item, and I am adding the fourth item. Here 1 is represented as the item is added in the bag, and 0 is represented as item is not added in the bag. Okay, so here when we check this, so what is this? 10 plus 10, okay, plus 0 plus 18. So what is this? This is profit, and we got the profit 38, and here weight is 2 plus 4 plus 0 plus 9 is equals to 15. This is a weight. Okay, so this is about the 0 by 1 knapsack problem using branch and bound technique. Okay, so thank you very much. We will see you in the next class. Thank you very much.